All right, let's look at going the opposite direction. Let's look at taking one of these sentences and turning them into a skeleton equation, one of those unbalanced chemical equations. First part of this is figuring out what you're dealing with. We have beryllium chloride, we have silver nitrate, we have beryllium nitrate, and we have silver chloride. Those are our four substances that we're going to be dealing with in our chemical equation when we finally write the thing. The first thing I would do is try to figure out what the reactants and products were. And to do that, I'm going to read that sentence and I'm going to look for some context clues that are in it. I see the phrase reacts with here. That tells me what came before it and what came after it are going to be my reactants. So my reactants are beryllium chloride, and silver nitrate. And then I see are made. This and this are made. That tells me those two things are my products. So my products are beryllium nitrate and silver chloride. One, if not the most important thing to do here, is to try to figure out what the formulas for these things are. Because we know we're going to have to put the formulas for these things in our chemical equation. So I got to use my rules of nomenclature. I have to decipher what that name is telling me and turn it into a chemical formula. I look at the name beryllium chloride, and the first thing I notice is there's no prefixes in that name. No mono, di, tri, tetra, etc. That tells me this is an ionic compound. I can further confirm that by looking up beryllium on the periodic table. Beryllium is Be. It's in group 2. It's to the left side of the table. That means it's a metal. I know this is an ionic compound. And when I have an ionic compound, it's all about oxidation numbers. I have beryllium and I have chlorine. The IDE tells me that's just the element chlorine. Beryllium is a +2. It's in group 2. And chlorine's in group 17. That makes it a -1. So I swap these oxidation numbers around. I got a 1 on the Be and I got a 2 on the Cl. So my formula here is BeCl2. Remember, don't write down the ones. And always make sure you can reduce if you can. This has a 1 and a 2, so that can't be reduced any. I have silver nitrate. That's ionic. I know it's ionic because two things. There's no prefixes there, no mono, di, tri, tetra, etc. And if I look up silver on the periodic table, it's to the left of the metalloids, so I know that's a metal. Silver is Ag. Nitrate, ATE ending. When I see an ATE ending, I know that I'm dealing with a polyatomic ion. Nitrate is NO3. Now, silver is a transition metal, but it is one of the transition metals that has a fairly predictable oxidation number. Silver is a +1. That's why they didn't put any Roman numeral in the name. It's a very predictable +1 ion. Nitrate's a -1. We have a +1, -1. We know we don't write down ones. That formula is just going to be AgNO3. Now we'll move on to the beryllium nitrate. We've done most of the work here. We know what the ions are now. We know beryllium is Be, and it's a +2, and we know nitrate is NO3, and it's a -1. The ions we have up here are going to be the same as the ions we have on the product side. So we already know what they are. We can just get down to crisscrossing and finding the formulas. Again, a 1 on the Be, so we don't do anything. The 2's coming over to the nitrate. Remember, put those polyatomic ions in parentheses first before you write the subscripts. And then finally, silver chloride. Again, we already know our ions. Silver is Ag, and again, it's a +1. And chloride is Cl. It's a -1. We have a pair of 1s again. So it's just AgCl. Those are the formulas I need to write my equation. And now I can just work through this sentence here and figure out where everything goes. I know when I put my substances into my equation, I'm going to have an arrow separating my reactants and products, with the reactants over here on the left and the products over here on the right. So I know these two things are going to go on the left. I know these two things are going to go on the right. I do need to though make sure I read that equation, include all the important information. This says dissolved beryllium chloride. So I'm not just going to write in BeCl2. I'm going to write in BeCl2 aqueous, aqueous meaning that it's dissolved. And it tells me it's dissolved silver nitrate. So when I write in my silver nitrate, AgNO3, I'm going to put that little AQ after it. And again, probably should have left myself a little bit more room there. So I can include that state with the formula. It's aqueous beryllium nitrate. So again, when I write the beryllium nitrate in, I'm going to stick my AQ on it. And it's silver chloride powder. Powder is another way of saying solid. So I give it the little abbreviation S. So again, as I'm doing these problems, the first thing I would do is try to figure out what my reactants and products are. I would read the equation, look for the sentence, look for context clues that tell me what the reactants and products are and kind of break them down and separate them. Then I'd figure out what all their chemical formulas are. And then I just go through, put my reactants on the left, my products on the right, separate them with plus signs so they don't all run together. And again, make sure that I find these little states, if I'm given them, to include the states. If you're not given the states, then don't include them in the equation.